Hi guys, well, this and the next video I think will be ones that are not planned. And why? Because this thing came today. A friend of mine brought me another one of this THS720 Tektronix fully isolated 3-channel, 2-channel plus 1 DVM scopes that I like. And of course the backlight was dead again. And this is why I made the first video, to show you more details about the designs I made, the third-party designs I made for this series, THS series. The first one is a fully compatible drop-in replacement from this to the CCFL controller to convert it to the backlight to LEDs. I made a video of that before, but yeah, it was from a time that I was just showing what I did, no explanation or nothing. Yeah. This time, with this video, I will go much deeper in details of the design, and I will show you the reverse engineered design, the reverse engineered schematic of the old CCFE controller that comes with this Tektronix oscilloscope with explanations, and my second design, that is an external battery charger. I have again a couple of videos for that, but none of them with schematics and details. So this is what we are going through today. So let's start with the CCFL converter that comes with the THS oscilloscope. It is this one, of course older design. It uses an TL1172 chip as a boost converter. We have here the boost coil, and the whole thing just drives an Royer style converter for the high voltage. So this is how it looks. The back side is, there's nothing. And even for that, they made a multi-layer PCB, I think, with this. I'm not sure. It is 2 layers or is it a multi-layer? Not sure about that. Anyway, so this is the one that comes with the original. Let's go now through the schematic. A little bit farther, more outside of that. The whole thing started, the first difficulty was to find this connector. Of course, there is no explanation on the schematics that I found on the internet about the THS700 scopes. There is no mentioning what connector that is, but I found it and I use it. Here you see the TL1172 boost. It just takes the 5 volt and boosts it to 12 volts. When it's operated, oops, out of focus, sorry for that. When it's operated from battery, and this is the coil I showed you before, and then here we have the Royer oscillator, or the Royer style oscillator. It's a self-oscillating design that gives you a sine wave at the output. You need, it is like a little bit like push-pull, but with a secondary, with an additional feedback winding that goes to the transistors. The switch transistors here we have. At the secondary part is the high voltage. We use here a dedicated current limiting capacitor. You say, why current limiting? Because at this frequency that this thing oscillates, the capacitor has a specific resistance, and this is used as a current limiting. Then we go, this is the side where the CCFL lamp is connected. I will show it to you in a minute. We continue there to a double diode package. The diode to the ground cuts the negative sine wave. The other one rectifies, and the current goes like that through the 1K5 resistor. The voltage drop across this resistor is sensed through this 10K and fed back to the feedback pin of the TL1172 boost converter, and this regulates the voltage. So it has a more or less stable output voltage on the CCFL lamp. This pin 5 here, to be honest, this resistor here doesn't even have a designator on the PCB. I do not really know for what that is. I'm not sure if it is not just to sense the voltage somewhere in the electronics of the oscilloscope itself. So this is the whole magic that is behind of this. Let's zoom it a little bit more. Why is this so bad? Yeah, behind of this quite old converter. It is a 90s design, what you see here. So, but because it is very difficult or quite difficult to get these CCFL ones, the CCFL tubes, and they are quite expensive. And honestly, it's a blast from the past. Yeah, nobody needs them again. I made a drop-in replacement for this thing. What is drop-in replacement? You will see. This one. So let's compare. Let's see if it can do that. Yeah, this is how it looks. The idea was just remove this and put this inside. I've seen a lot of videos on YouTube where people making this upgrades to a LED backlight, but honestly, without want to say something bad, it is a botch job. Yeah, they are taking cheap converters from alley, glue it with hot glue somewhere. It looks awful. I don't like these things. I like things to be made tidy and as much professional as possible. So this is why I designed this thing. This is my converter. It uses the original connector that the CCFL board has on it. The only difference is that the output is no CCFL, but it is a 3mm LED strip. And you can see when I did that. April 22. This was my original design. I shared it on EEVBLOG. Quite a few people copy it, make some changes and use it. A few of them change it and just put the trimmer here. I do not like moving parts here. So I used jumpers, solder jumpers for 4 different voltages that you can use. So that's my design. This thing is as a shared project on there was too much light here. It's as a shared project on PCBWay, or if you want, just drop me a mail and I will send you the design files for that. And this is to drive this small LED strip. This thing is very, very bright. You can adjust the brightness with the solder jumpers. It is connected directly, and it's a 3mm strip. Informations about that I will put in the comment section or in the description, in the description of the video. I used for that cold white LEDs. I like it more. So you can connect it here. You can choose between a SMD connector or a through-hole connector for that. So that's the whole thing. Is it broken? No. Just a reminder, if you like my videos, if you like my content, please consider subscribing my channel, hit the like button and the notification button. All of this helps me to grow the channel and to show you a lot of more in the future of designs, teardowns, perhaps repairs, even to some exotic stuff in electronics, of course, yeah, and many more. So this was the first design I made. It's, as I said, in the PCB shared projects shop is, I think, yeah. And now I want to show you the next one, what I made. Yeah, I almost forgot. Here we have the datasheet of the original chip that is used on the converter. Let me zoom in. That's the chip here. Of course, I could have used this chip as a boost converter too, but this chip is far more expensive and quite old compared to the one I used, and I will show you the datasheet in a jiffy. It's, as I said, a chip from the 90s. It works good. It is only in 100 kilohertz, and it can go up to 1.25 amps. The one that I use is called SX1308. It's an Asian chip. You know me, or I think you know me. I like to use as much as possible Asian parts, and with Asian parts I mean mostly highly integrated chips like that, because they made chips that are for cheap, do exactly what they should do. Not too many, yeah, it does that and does that and a little bit of that, and then you have to adapt. Okay, yeah, it's not exactly what I want, but I can live with it. No, they make chips that are to the point, that are working exactly what they are designed. And this is one. It is not the newest one, but it's a much modern one. It's a 1.2 megahertz current mode step-up converter. It goes up to 2 amps. And this thing has a SOT 23.6. It's a very, very small package. It's the half of the size of the LT chip that is a SOIC 8. So this is why I use this chip. I use it a lot. Not this one. This one from Aerosemi. It's easy to use. It works perfect. And it goes up to 28 volts instead of 24 volts of the LT chip. I think it's 24 volts. Nope. Sorry guys. The positive on the linear chip is that it goes up to 60 volts, but I don't use it for that. I don't need 60 volts. So anyway, this is the chip I used. Now I want to show you the second design I made. So, of course, this is not the design I made. This is the electrons will fall out, Dave Jones would say. This is the original external battery charger from from Tektronix, sorry. I think I'm reading tech and I'm thinking of tech, digital equipment. Anyway, this thing is not really easy to find and it's not the cheapest one. Yeah. So, and it is only for nickel cadmium batteries. So my design is this. It is to charge both nickel cadmium and nickel metal hydride batteries. I'm really disappointed to show you that. I'm really embarrassed because I broke it. It's a 3D printed part, and I treated it like if it is a injection molding plastic, and of course it wasn't. I make a bigger hole with a little bit too large drill, and it cracked. Yeah. I do not have any experience with 3D printed parts. A friend of mine made that. The first one, this is made of PCB way. The first one cracked because it was a material that, I don't know. It is a big difference between injection molding and 3D printed stuff in the rigidity. This is what I saw. Anyway, even that I cracked this, PCB way sent me another one with another material. This thing is Teflon, or no, it's nylon, and it should be much more rigid. Embedded brass inserts. Anyway, so this is this is how it looks. It consists, the 3D part, the 3D printed enclosure consists of this part. Now you see the big hole. This cylinder for the battery and the bottom. And this is my design. We have a polarity protection. This is much better. We have a polarity protection for input voltage polarity protection with a fuse. Why does not? Here we have with a fuse. As a default, I use, I don't know how to hold it to make it focus better. It focuses on the screw anyway. You can use it with a 12 volt or a 5 volt power supply. Now I'm using with the 5 volt. If a 12 volt power supply is used, a ready-made DC-DC converter is soldered in. Protection. Here I have an 80 tiny. You cannot see that. Here you see it. The 80 tiny. To be honest, the 80 tiny is only for nothing else than to drive this intelligent LED with a WS2812 chip inside. It's just for the indication of the status of the charger. So let's go a little bit further down. And here we have the whole magic. As I said, I'm a big fan of using Asian chips like this one. The here you have it, CN3387. It's a specialized chip just for nickel metal hydride, but I read on the Battery University that a nickel metal hydride charger can charge nickel cadmiums too without any problem. The opposite is not to be done because of the higher currents. It's a switch mode driver that charges the battery pack. These are the mechanics. All of this with informations will be in the description of the video. And I'm not sure if this thing is easy enough so I can put it on PCBWay shared projects. I don't know. Anyway, from everything but you see, you can have the step files for the 3D printing, the information on the mechanics with parts, etc., the schematics and the design files. Just drop me a mail or no, write me in the description, put a request, and I will send it to you. So let's see the schematic of that. This is a little bit more complicated than the CCFL converter, of course. And we start on, the input with a 3mm barrel, with a 5mm barrel connector, 2 amp PTC, reverse polarity protection. We have here the DC-DC that is used if we have a 12 volt input. If a 5 volt input is used, then this solder bridge is closed. Some LC filtering with a ferrite bead and a capacitor to give as much as possible a clean voltage to the input here. Again, some filtering and buffering, reservoir capacitors, overvoltage protection, that if something happens, the voltage will be clamped to 7 volts because this one clamping voltage is 7 volts. And here we have the whole switch mode charger circuit with a feedback on the output that monitors the charging progress of the battery pack. And of course, I use that too to monitor the status. I'm using the analog, the output as an analog input on the Tiny 85, again with protection, input protection, and the status output of the CN3387 too. As I said, this thing is only to show you 4 statuses, because I don't know why all these chips are very, very stingy with the status information. So I had to combine analog and digital and to show the status using a small program, a little bit of code on the Tiny 85. This is the whole thing. Yeah, and here is the VS2812 intelligent LED that shows at the end the status. Programming interface for the Tiny, and that's it. Yep, this is the whole design. Again, to be honest, the mechanics were the biggest challenge for that, because I searched a lot what I can use. And you see here, I have a spring, boing, 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 just to make the whole thing a little bit smoother. And again, it is, all the design files are available on request for this and the CCFL converter and the 3D printed part if you want. This is the opening for the status, because inside it is more than enough, this distance, this big distance is no problem for the high intensity of this LED. I'm already using it at I think 60% only density, otherwise it will be too much. So what else can I say? Yeah, let me show you the chip. This is the chip what I'm using, the charger chip. It's from Consonance. It's a multi-cell nickel metal hydride, but can be used for nickel cadmium too. I will put a link on the Battery University where this is dedicated. This is stated, stated, wrote and dedicatedly. I don't know if this is a word what I'm using now, but anyway, is a SOHC10 10-pin package, and does exactly what it is intended to do. No more, no less. The only thing I would like on this chip is a little bit more information, a little bit more status information, to just not have to use a microcontroller for that. So, that's for today. The reason why I did this video now is because my next video will be the upgrade of the scope itself to a LED backlight. Good. Let me show you that again. That's for today. Thank you for watching. Please subscribe my channel, guys, and hit the like button. See you next time. Bye.